Wasteland Coder here again. Today we're going to take a look at EclipseLink. We recently did an upgrade from an old version of TopLink from about the Bronze Age to a newer version of EclipseLink. And we ran into some issues in that upgrade around deadlocks, or what appear to be deadlocks. So today we're going to look at a class in EclipseLink, some of the code in this class called Concurrency Manager, and all of the code we're going to look at today is in this Concurrency Manager class. So let's start with one of the culprits that one of the suspects we were looking at, this release deferred lock method. We didn't really know what deferred locks were when we started digging into this code, and it's still a little bit fuzzy, but it seems to be a way for EclipseLink or in the old TopLink to basically say, I need to read this eventually, but I don't really care to wait around and have it read right now, so just defer the lock on reading something. This is for like eager fetching of joined data, basically. So it will kind of register, I want to read this, but I don't need to wait around for it, and we'll read it whenever it gets around to it at a later time. And so this release deferred locks, it goes and kind of cleans up all those that it was waiting on previously. And so this of course is a bit of an eyesore code, but we can look at it and you say, I can't really read that down here. Well, that's because we don't have good IDE giving us help for where the brackets start and end, but we can fix that. But the meat of this method is in this while loop here. And it's a busy wait. We can read the comment here about thread having 3 stages. One where it's doing work, second where it's done with its own work but waiting on another thread, and then third where all threads are done. And so this is the loop that goes over waiting for objects to be built and the work done. So first it builds up this identity hash map, then it'll use to pass in to a call here. This is build object on thread complete is the one that kind of checks, hey, is my work done? If so, it'll go in and remove the lock manager and get out of the method. If not, it'll sleep for a little bit of time, 1 millisecond, and then go through the loop and try again. If we look at the old version of TopLink, it did something very similar. The only real difference in this one is that it sleeps for 10 milliseconds rather than 1 millisecond, so that's not a huge deal. It still calls this as build object on thread complete method, and it uses a identity hash table here rather than the identity hash map in the old one or in the new one. But, those are the only significant differences there. So if we dig into that is build object on thread complete method in EclipseLink, we can see that it also is a bit of an eyesore. It's got this big loop in if statements again that we don't have an IDE to help us, so we can match these brackets. But it's a recursive call, so that's going to call itself there. First, basically what it does is it checks to see, hey, do I have this key yet? Have I seen this thread yet? If so, just return true. Otherwise, mark it so that we don't have to look at it again. and then it starts doing some work, gets the lock manager for that thread, checks if it's null. If it is, assume the work is all done, return true. Otherwise, we're going to get the deferred locks and iterate over the deferred lock, the concurrency manager deferred locks inside of the deferred lock manager. And the first thing we're going to see is if the deferred lock is acquired. So like I have done work, or I need to do work, or something like that. If it doesn't, it's just going to go through the next one in the loop and check it. We're going to look at the active thread on the lock that we're currently looking at. If that's not null, get the deferred lock manager for that active thread. Again, right, deferred lock manager, it's coming up all over the place. If that guy is null, then assume we haven't finished our work yet and return false. Otherwise, we're going to check if that guy has finished his work. Is thread complete? If it is, we're going to get the active thread again and see if it's null. If it's not null, we're going to do the recursive call with that active thread, passing in our set. And if that guy does not return true, we're just going to return false because it's not done, so we're not done. So it keeps going. And then also if the current lock manager is not null, but the thread is not complete, return false. Looking at the old version of TopLink, it does basically the same thing again. One difference that we can see right off the bat is it's a synchronized method. And then the actual logic of it is very similar. Uses a while loop rather than a for loop, but that can be just, this is decompiled code rather than source code, so that may just be a difference there. And one of these if statements is a little bit different here, where it's doing the recursive call. And again, that could be a difference in how the code is decompiled rather than how it was actually built. So the logic here is very similar to the new EclipseLink, but we were seeing threads get stuck in EclipseLink when they weren't getting stuck previously in TopLink. So something around here may have changed when we were digging into that. And one item that we noted was that obviously it's synchronized here where it isn't in the new one. So why might they have removed that synchronized code? Because this seems like it should be synchronized. It's getting this active thread, which is just a instance variable, and really that should be accessed in a kind of synchronized way so that we can reliably see updates to it and everything, but it's doing the double check on it, so like that's just kind of weird. But like, is it going to cause a problem? Maybe you just go through the wait an extra time, which wouldn't really be too bad of a deal. Like, we can kind of see how a bug may exist in here. It's kind of complicated code with the double checking and all this. It's concurrency code, which is always a bit of a pain to work with, and all sorts of different kind of issues can crop up. But let's dig into why they may have removed that synchronized keyword. And so they may be trying to kind of condense down the area that Java needs to lock the code for access. And so one of those areas could be this deferred lock manager. And so in the new EclipseLink, this is the method for that. It gets the deferred lock managers and just calls get. Well, that doesn't help us much to see what it's doing. So get deferred lock managers is a map That still doesn't help us much. It says hash table up here. That's a bit disconcerting. Okay, so how is that initialized? Up in the constructor, it calls this method initialize deferred lock managers, which is a concurrent hash map. Oh, so that one is safe. It's thread safe, so you can access it. It has its own mechanism for locking itself, so you can reliably access it with multiple threads. So if they were able to push what the synchronized in the old code needed to be synchronized on into this deferred lock manager collection, then you can safely remove that synchronized code. I cannot spell synchronized. And so what did they have in the old version of TopLink? Back here, get deferred lock managers, manager, does a very similar thing, get deferred lock managers, and that one looks like this. Oh, it is a hash table. So in the new version, they just didn't update their comment apparently, because it still says hash table there. But if it's not initialized yet, initialize it, the new hash table, and then just return it. Hash table is not safe to be accessed with multiple threads, and so that may be the reason that they had to add synchronized around the whole block of code here, is because you couldn't reliably access that hash table. And so that may be one reason that they were able to get rid of the synchronized by stripping down the lock to where it actually needed to go around that deferred lock manager collection that they had. We have since found that this isn't actually the problem. There's a way to turn off deferred locks in EclipseLink, and so we did that, and the problem that we saw is still there. So it's likely this code isn't involved at all, but it was something that we had to dig into, and so you get to dig into it a little bit with me too. Thanks for staying here through this. See you next time. If you like looking at EclipseLink and TopLink code, please like the video and also consider subscribing. Thank you.